Okay. Hey, hope you guys are doing well. I'm here today to talk about Eclipse and bringing the SVM to more builders and why rollups need to do more as well. Obviously, we have a pretty saturated rollup landscape in general in the Ethereum world, and Eclipse in a nutshell is bringing the SVM to Ethereum. And so I'll talk more about what the broader rollup landscape needs to do and how Eclipse fits into that, specifically in terms of bringing that SVM over to Ethereum. So first, I'll touch on what is Eclipse. So Eclipse pioneered the SVM scaling category and launched mainnet on Ethereum in Q4 of last year. So we've been live on mainnet for about 5 or 6 months now. And in a nutshell, Eclipse is a modular stack. So we're combining the best of all worlds in terms of each piece of the rollup stack. So at the VM and execution level, we're leveraging the speed and scalability of the C-level virtual machine, called SVM for shorthand. And at the security layer, we're settling to Ethereum, so inheriting the security of Ethereum as an L1. And then we're leveraging the liquidity and network effects of ETH as a gas token. So this is leaning into the moneyness of ETH specifically, and as opposed to Ethereum as kind of a broader network. And then at the DA layer, we're leveraging the bandwidth and the verifiability of Celestia and ZK fraud proofs with risk zero. So this is the Eclipse stack in a nutshell. And in terms of what output that creates, it allows us to be the highest throughput and lowest cost chain on Ethereum right now. So I'll talk a bit more about network stats in a second. But just to give you guys a sense, so far since we've launched mainnet in the last 6 months, Eclipse has been the largest publisher of data to Celestia by a very wide margin. We've broken the TPS records for any L1 or L2 out there. I'll talk a bit more about that. So we've seen extremely strong demand and usage in the first 6 months of mainnet. Obviously, a lot more to do and a lot more performance improvements to drive and apps to onboard, but it's been a great start so far for the last 6 months. And over here on the right, you see a breakdown of what's happening with Eclipse. So as I mentioned, at the execution layer, you've got the SVM. The block is posted to Celestia, and then the commitment posted to Ethereum, and there's a validating bridge and settlement is happening there. And then the Merkle root is relayed over as well. So I'll talk a little bit about metrics to date. So as I mentioned, Eclipse has been on mainnet for the last 6 months. And so far, we've generated close to 1,100 ETH in fees from usage of the network. And then in terms of throughput, we've reached 3.5K sustained TPS with 250 million transactions per day. And so that breaks down roughly to about a few thousand transactions per second on a consistent basis. In terms of total number of wallets, 1.1 mil, and total lifetime transactions is north of 20 billion, with the median fee of a fraction of a penny. So going back to my previous point about how Eclipse is the highest throughput and lowest cost chain on Ethereum, this is the breakdown in terms of how it comes out to fees to post data. And there's an interesting stat here. So right now we have about 40 apps deployed on Eclipse. It's a breakdown of roughly half Solana blue chip apps that have been around for a while, and then half Eclipse native apps. So examples of some of the existing Solana apps that have deployed to Eclipse are players like Orca and Save, which had rebranded from Solend. And so these are players who've been established on Solana for a while, and they deployed to Eclipse in an effort to tap into Ethereum users and assets. So that's where the SVM expansion aspect of Eclipse comes in, where it's allowing these established Solana apps to tap into Ethereum users and assets and broaden their user base and growth. So we tend to see it more with established apps who've been around for a while, whereas younger apps who've just launched tend to stay on Solana. So that's roughly about half the app base, and then the other half is Eclipse native apps who've built and deployed natively to Eclipse. And of course, they're developing in Rust as well, right? So since we use the SVM, Rust is still the language that they work with. And so that allows us to kind of help to also broaden out the Rust base. And then in terms of other things that we've seen on the network early on, there's been a fair amount of DeFi. So particularly in terms of Sol ETH DeFi, those are the two assets that we've seen the most activity in, as well as TIA, just given that we're integrated with Celestia as well. And then we're also seeing a fair amount of activity with liquid restaking tokens and collateralization use cases involving those as well. So I'll talk a little bit about our performance to date. So as I mentioned on the previous slide, we've reached a 3.5K sustained TPS, non-voting, and then we hit a peak TPS of 8.6K, which was driven by a couple of apps that saw extremely high usage in the first few months. And then under lab conditions, we've achieved throughput surpassing 100K TPS. And then right now we're moving towards north of 1 million TPS in terms of hardware-based improvements, hardware, software, co-design, and some other things I'll talk a bit more about in a second. So I want to talk a little bit about our performance thesis design principles. So this is what we're doing to really drive towards north of 1 million transactions and beyond, as I was mentioning. So we recently published a paper about this in March, which outlines our thesis around this and how we're going to get there. But in a nutshell, we're taking different approaches per transaction processing stage. So at the network piece, the runtime piece, and the database piece. And specifically, we're leveraging hardware improvements and hardware acceleration that is pretty common in the LLM world at this point, but hasn't seen too much usage in the blockchain space yet. So tapping into that along with optimized hardware software co-design to really drive those performance improvements. And then additionally, there's cross-layer optimizations, non-interference. So you don't need to have L3s, which of course is a common topic these days. And then dynamic scaling and chain elasticity as well. So you provide enough capacity to scale based on what applications are demanding. So this is all work that we're working on right now over the next year to drive towards that concept of giga compute, which is the term we've coined to basically capture the order of magnitude computational improvement that we're seeking to drive, specifically as an L2 can do, right? Because Eclipse is a layer 2, so we're not subject to the same constraints as a layer 1 in terms of decentralization and security. So that allows us to lean into the specific set of things that a layer 2 can do extremely well, which involves having a more limited sequencer set. So limited, but still verifiable, and essentially have a rotating sequencer set as well. So that's the approach we're taking, and which largely is in opposition to what you see in L1s now, right? Where there is an effort to fully decentralize. But Eclipse as an L2 can inherit the security properties of Ethereum. So that allows us to focus on that piece that an L2 can be extremely good at. So I'll talk a bit about where app activity has been coming from so far. So first is an app called TurboTap, which is a relatively simple tapping game. It's a genre of game that has come back a lot recently. And that game saw close to 320K total users and 370K quests completed. And so there was a series of mini games that were part of this app, and it was kind of very easy to play viral game. And then some other stats, peak transactions per day were 270 mils. So this was one of the two apps I mentioned that was driving a lot of network usage. And then total transactions lifetime was 14.4 billion. Next is an app called Bits, which if you guys are familiar with Ore, is a relaunch of Ore on Eclipse. And that has started to see a lot of viral community and usage develop around it as well. So total transactions so far is 42 mil, total miners 24K, and average mining transactions per hour is 136K. And then we also have this app called Beacon that's in the process of launching now, which has seen peak TPS of 750 transactions per second. Beacon, in a nutshell, is a decentralized AI data marketplace. So it allows users to monetize their on-chain data for usage for training purposes by Web2 applications. So it's kind of a Web2 Web3 crossover. And then some other apps we have in progress to take advantage of the throughput Eclipse offers are commodities and FX perp decks, 6v6 showdown game, fully on-chain civilization game, and AI agents, as well as social speculative asset experiments. Of course, Solana has seen a lot of this as well. So now I'm going to shift gears a little bit and talk about like what rollups need to do more of, right? Because I'm sure you guys have all heard of extremely high throughput, high performance rollups in Ethereum world. Even in the broader SVM space, we're seeing more proliferation now. So I think it's important to chart out a course of like what is the most impactful role that a rollup can play today in terms of differentiating itself to builders and becoming an attractive place for app developers. And so I'll talk a bit about the things that may have been value props that even ourselves and others out there have focused on to date, but today is not enough in isolation. And then at the end, I'll kind of wrap up with how we're thinking about that and using that to inform the next year ahead of us as well. So first is on performance, right? So obviously we've all heard huge performance claims and TPS claims, and block space at this point is largely commoditized, it's fair to say, right? It's table stakes. You need to be extremely high throughput, and a lot of app builders are expecting that. There's also a lot of use cases that don't necessarily rely on that, right? So if you look at some of what's happening in the RWA world, it's not necessarily high throughput, but it's more about different type of app experience that leans into certain type of compliance protocol or user experience that's applied on top of it. So in terms of performance, though, by end of year, there's going to be 5+ chains that are capable of running an on-chain order book DEX in terms of raw throughput, right? And let's just park the idea of latency and MEV for a second here. But if you look at the EVM world, you've got GigaGas that's already live on testnet and then is being productionized by MegaETH, Say, Monad, and then multiple high-performance SVMs, both layer 2s like us as well as L1s are heading into production. And then Eclipse on mainnet has processed close to 10K peak TPS and then is aiming for 2 orders of magnitude improvement from here. And then if you look at the application-specific sequencing world as well, right? So you have this aspect of customization and being able to break down sequencing by apps. And you get this idea of custom chains with ZK proofs or on-chain risk engines and liquidation engines with off-chain matching. These are all highly performant environments that retain sync composability and these shared characteristics with the L1 and L2, right? So TLDR is like performance is much more commoditized at this point. We're seeing this in the SVM world, of course, but also EVM and more broadly. So that's on the performance piece. Next is economics, right? So prior to working on Eclipse, I was involved with the early launches of DYDX and Uniswap. So these are established Ethereum blue chip DeFi players. And what's happened with a lot of players like that is they've shifted more towards siloed environments, right? So in the case of DYDX, they moved to an app chain that's Cosmos based. In the case of Uniswap, they moved towards Unichain, which is an OP stack based rollup. So what you're seeing in Ethereum world is this kind of development of these kind of isolated islands that don't really share liquidity with each other. And there's a strong motivation for that though, right? And that's to own economics. Because if you look at the most established apps out there, they're generating a tremendous amount of fees and revenue, and they want to capture that, right? Because right now that's just going all to the L1 or L2 out there. And so what they're doing is they're vertically integrating to capture this additional value. And the way to think about this is like if the net benefit of shared liquidity distribution to users is surpassed by the revenue that I can make, then I'm going to make that move to an app chain or to an app specific environment rollup. So in response to this, what have infrastructure players been doing is they've been moving towards fee sharing models. This is something that we're doing as well. I think it's something that will become table stakes at some point. You first saw this with Blast in the L2 space, and then on the L1 side with Canto CSR. Sonic is doing it as well, notably. Andre has been tweeting about it. And then also the Solana Foundation has been experimenting with multiple concurrent proposers with priority ordering. And then you also have MEV taxes, SIMD 110, which reduces the incentive to send non-executing transactions. So they're all kind of expressing this desire on the part of builders for app pricing power instead of block space just accessing their state. So another way to think about this in terms of like Web 2 jargon is it makes sense for highly fragmented, high margin industries. You want to roll up those types of businesses with low margin at scale entrants. And so you're kind of having this compression where infrastructure is sharing fees with apps, and apps will go where they feel they can capture the most value that they are generating. So at the very minimum, these app builders want the proportion of economic value or revenue that they create specifically. Next is on customization. So apps want customization as well over sequencing, and this is not an execution consideration, right? So Eclipse actually got its start doing rollups as a service software. And we moved away from that because we realized there was an opportunity to build a singular monolithic rollup that could meet the needs of what developers wanted and be very opinionated about that, right? So use the SVM at the execution layer, accelerate performance, return economic value to developers. And there's also an opportunity to leverage application-specific sequencing as a layer 2 rather than providing all these separate rollups to each app. So, if you look at RAS over the last 2 years, there's no significant examples or unlocks of execution customization that isn't related to making transactions faster, cheaper, or ordered in a specific way, right? So simply put, application-specific sequencing is superior to RAS or deploying a series of app-specific rollups because it gets you to the same outcome, along with capturing a proportion of the economic value that you create and a high-performance environment. So examples of this are, you see plenty of these out there, but maker order prioritization for perps and spot dexes, and of course, trading is huge. And market makers and liquidity providers need their maker orders prioritized in order to have a healthy liquidity environment, right? And this is something that Hyperliquid got right, where they thought a lot about transaction ordering that made sense and the specific type of sequencing behavior that was important. And so you can get to that same outcome through application-specific sequencing on a layer 2. Next is NFT minting platforms that enforce true first come, first serve. So an example of this is Chainlink FSS, and then proof of humanity prioritization with WorldCoin. So thinking about what are the types of behaviors that are relevant for the app in question and thoughtfully prioritizing in a way that makes sense for that app. So that will become table stakes as well and is something that we're executing on in terms of application-specific sequencing. Next is reliability, right? So transaction landing, reliability, and fee estimation user experience. So Ethereum solved this with EIP 1559. It has been an issue on Solana so far, but that's being addressed on multiple fronts, right? So through SIMD 253, which increases target block space utilization to 90%, SIMD 110, which reduces the incentive to submit non-executing transactions, and dynamic base fees. But TLDR, this idea of reliability is important as well, and chains need to be thinking about how they're going to support that. And then you have MEV resistance, right? So this alone is also not enough, but put together with the prior slides and the topics I was talking about can be a compelling solution for builders. But this is really the last piece in terms of getting to this amazing user experience and developer experience. And also, I think one thing that's important here is rather than trying to boil the ocean, address issues in sort of this iterative, path-dependent way as they arise. We're seeing a bunch of interesting things here, right? So first is custom ordering or batch auctions with a uniform clearing price, request for quote platforms, the validator whitelists with the proof of authority sequencer or trusted execution environments, MEV-resistant DEX design, and private RPCs, right? So all these solutions are seeing multiple players at this point, and there are different ways of getting to this idea of MEV resistance. It doesn't have to all be at the infra layer. but it can be. And then lastly is users and liquidity, right? So in this crowded infrastructure landscape, network effects, users and liquidity offer a huge point of differentiation and make it easier for app builders to get started, right? So a way to think about this is that chains, both L1 and L2, are distributors, and they build a base layer of liquidity for the app ecosystem. And DeFi, in my view, is always downstream of creating interesting assets on chain, right? So you kind of need this base layer of users and liquidity, and you start to see interesting assets, and then a DeFi ecosystem develop around that. And of course, Solana at the L1 has executed on that in an amazing way. But I think it's important to keep that in mind, that that is a huge point of differentiation, regardless of what you're able to provide in terms of the prior topics I discussed, like MEV, performance, economics. And chains are taking different approaches to this, right? In the case of Starkware, they're leaning into BTC as a top traded asset. Because if you look at most chains or most DEX environments, the most volume is in their native token, as well as BTC, maybe ETH, the top assets, right? So that's like, there's this power law distribution that always remains constant. So thinking about that and ways to tap into that is a way to help bootstrap ecosystems as well. You can see that in the hyperliquid spot markets as well. So this brings me to the conclusion here, which is that taking the prior topics I talked about in isolation is not sufficient to create a compelling enough solution for app builders, but rather it's about the totality and packaging all those things together that makes for that interesting environment, right? So what a compelling infrastructure solution for app developers needs to have is high performance, incentive compatibility, MEV resistance, high reliability, app order customization or application-specific sequencing, along with a high user count and a high liquidity environment at the execution layer. So this is the product experience that Eclipse is driving towards. And again, we're leaning into the things that layer 2 can uniquely do. And our view of what this looks like is a hardware-accelerated SVM layer 2 that offers fee redistribution back to app developers based on the economic value that they create, proof of authority sequencing, and trusted execution environment builder, and then leveraging SIMD 253 to get to that target 90% block space utilization, along with application-specific sequencing. So our view of the world is really that one rollup is all you need, and we're seeking to build that rollup for Ethereum, but you need to bring together all these characteristics I talked about to create this compelling environment for app builders. So obviously it's an arms race now, and we're very much focused on these things I talked about here. But in order to really, if we're looking at Ethereum world, in order to really build something that can attract a mass base of developers and drive those network effects, it has to involve these characteristics. And so that's the view that we're approaching the world with, and what we're focused on for the next year. Thanks. That's all I had.